All right, so today we're talking about rotations. So far we've talked about translations, reflections, a couple of different other types of transformations and translations, but today it's rotations. So a rotation is the action of turning or spinning around a center of axis. Well, usually it's the origin or something, some other point that we can define. If you're watching from home, take a look at this little video link, and you'll see a cute little video about rotations that will help you understand it a little bit better. Now, when we talk about a rotation around a point like the origin, we usually use this picture of what we call the unit circle. If you go all the way around one turn around this circle, you go 360 degrees. Each quarter of a turn is represented by 90 degrees. And so as you can see, 1/4 is 90, 2/4, 180, 300, 3/4, 270, and all the way around is 360 degrees. So keep that in mind. So here is a few definitions that we want you to definitely write down in your notes. So a rotation rotates a figure around a fixed point called the center of rotation. For our examples, the center of rotation will be the origin and will rotate in increments of 90 degrees. So pay attention to the direction. So this little arrow that shows us rotating to the left, like this, is a representation of a clockwise rotation. This other arrow where you rotate the other direction toward the right, that's considered a counterclockwise rotation. And you can also consider that each quadrant is another 90 degrees in the rotation. All right, so here are some pictures that I'm going to do an overlay on each diagram, and we're going to rotate the original figure to the next figure, the one that has a little mark on it, the prime figure. And we're going to see what type of degrees it takes to go either clockwise or counterclockwise to go from one picture to the other. When I get done with this little video, we will summarize our data. Okay, so we're going to show you a couple of rotations here. So if I rotate A from the initial point to the A prime in the clockwise direction, that's a 90-degree rotation. So if I go the other way, all the way back around, that's a counterclockwise rotation of 270 degrees. So that's quite a big one, huh? Okay, so next we're going to go with B. We get B put into place there. Okay, now if we rotate this one counterclockwise, we'll go counterclockwise first. Counterclockwise, that would just be a 90 degrees counterclockwise. If we go clockwise, in order for B to get back to B prime, that's going to take 270 degrees. Okay, good. Let's do C. All right, so we've got C nailed down there, and we're going to rotate C up to this point right here. So if we go in a clockwise direction, there's 9180. So that's a 180-degree rotation. If we go counterclockwise the other direction, then it's also 180 degrees counterclockwise. Okay, good. All right, so we're going to go with D now. So we've got D here in quadrant 1. Okay. And we're going to rotate it so that it goes on to D prime. So if we go clockwise, that's 90, keep going, 180, 270. So 270 degrees counterclockwise will get us back onto D prime. What if we go back to the original image and go counterclockwise? It's going to be a 90-degree counterclockwise rotation to do that. So as you can see, some of these rotations end up in the same place. We just got to go a different distance. Okay, so let's get our last couple in. We got number 5. which is E. And we get E now down here. So we got E down here in quadrant 3. We're going to rotate it clockwise. So 90, 180 to get over there. So there's a 180 degree rotation. So I think if you go counterclockwise, it's also going to be 180 degrees counterclockwise to get back on there. Okay, and our last one is F here. So we'll get that right where you can see it. Get it centered on there. Okay, so we're going to rotate that clockwise. 90 degrees is going to put us on the new F. Okay, so what if we go counterclockwise? We have to rotate all the way back around. And each quarter turns 90, so there's 180 and then 270. So 270 degrees counterclockwise rotation. All right, so here's a summary of the data that we saw in the demonstration. So the clockwise rotation was 90 degrees, counterclockwise 270. And this one, we had a clockwise, we had to go all the way around, and that was 270, and the counterclockwise was only 90. And this one, 180 degree rotation either direction, will put us from the original image to the new image. This particular one is another one where in order to go clockwise, we had to rotate 270 degrees to get to the new image, or just 90 degrees counterclockwise. This is another image where the rotation, either clockwise or counterclockwise, was 180 degrees. And this last one, another example of a 90 degree clockwise rotation or 270 degrees counterclockwise to get us where we wanted to go. Now here are some rules. We're going to hand you out a piece of paper in class, or you'll be able to print off of our website. These are the rules for each of the different kinds of rotation. So for clockwise rotation, a 90 degree, 180, or 270 degree rotation will result in this change in the original coordinates. So if you know the original coordinates, and if you follow this rule, you can write the new coordinates after that rotation. If you want to look at the counterclockwise rotation rules, these are listed right here. Okay, so let's practice a couple. Rotate the figure shown at the right 90 degrees, then 180 degrees, then 270 degrees clockwise. After each rotation, record the coordinates of the image in the appropriate table. Look for any patterns or try to create the algebraic representation for each rotation. So let's try the first one. So if we do a 90 degrees clockwise rotation, and we end up with these new coordinates. And what we notice is that the x and y values change places. So the 2 and the 1 swap, and then whatever number's in the y place changes its sign, so it becomes its opposite. So let's try the next one, the 180 degree clockwise rotation. So in that case, we rotate to the third quadrant here. And what happens is the numbers stay the same, they just all switch signs. So instead of being both positive, they're now both negative for each of the vertices on this polygon. And for our last rotation, our 270 degrees, putting us up in quadrant 2, we notice that our new values look like this. So all of the original y values are now in the x position and have become their opposites. All of the original x values are now where the y values used to be, and they don't change sign, they stay the same. So basically what happens, xy becomes negative y comma x. And there's kind of a summary of what's going on. So if you get good at these rules, you can pretty much predict what the new coordinates are going to be. So the coordinates below represent rotations. Use what you've learned today to describe what type of rotation occurred. So in number 8, the rotation that occurred was a 90 degrees clockwise rotation. And number 9, to go from -4, 5 to -5, -4, that would be a 270 degrees counterclockwise rotation. To go from -6, -1 to 6, 1, that would be a 180 degrees clockwise rotation. Number 11, do rotations preserve or change the orientation of the figure? They change the orientation of the figure because it's rotating around that axis. Do rotations preserve or change the orientation of the vertices? They also change because they're all in different positions or different quadrants, so they change. So let's summarize today's lesson. Rotations spin a figure clockwise or counterclockwise around the origin. This causes the vertices to change in predictable ways. So these are what we're going to be doing for our worksheet. And so let's take a look at the first couple of problems and see how that works. So what we're doing here is we've got the original coordinates of our figure here in quadrant 1. If we rotate it or take it, we want to find A prime after a 90 degree clockwise rotation. So if we do that, let's just show you what that looks like. We know that in a 90 degree clockwise rotation that the original x and y becomes y comma negative x. And so you could take any one of those coordinates, and so that was A. So A prime is now 7 comma negative 2. The next one, B prime, after B is rotated 270 degrees. Well, we know that a 270 degree rotation will result in xy becoming negative y comma x. So if xy started out at 7 comma 7, then negative y would be negative 7 comma 7. So let's do one more. So let's find C prime after C has been rotated 180 degrees. So in a 180 degree rotation, x comma y become negative x, negative y. So my original coordinates 7 and 1 became negative 7 and negative 1 because of that rule. So let's take the time to get to know these as best we can, get this done, and then tomorrow we'll work on some more problems and see how far we can get our data recorded on Canvas as well. Thank you very much.